Dear students, in organic chemistry we come across electrophiles many times. Now today let's see what is an electrophile. An electrophile is an electron loving. Phile means loving. So it is an electron loving species. So it is an electron deficient species. Since it is electron deficient species, it loves electrons. That implies the central atom's octet is incomplete and the central atom has 6 electrons. A good example for this is carbocation CH3 plus. The plus sign is on the central carbon atom. So it is forming 3 bonds with hydrogen atoms. So the central carbon atom has 6 electrons and it has a plus charge on it. So it is an electrophile. Here the central carbon atom's octet is incomplete. Hence CH3 plus is an electrophile. Now let's see what is an electrophile. Definition of electrophile. An electrophile is an electron deficient species that accepts electron pair from electron rich species. Electron rich species are nucleophiles. Okay. Electrophiles are therefore electron deficient species, hence electron loving species, and they accept a lone pair of electrons, so they behave as Lewis acids. Lewis acids means the species that accept electron pairs are called Lewis species, Lewis acids. Okay, these are. Now let's see what are the types of electrophiles. Electrophiles are two types: positive electrophiles and neutral electrophiles. Let's see positive electrophiles. H plus ion, that is hydrogen ion, has no electrons in its valence shell. It should have 2 electrons to become stable. So it is an electrophile because it is in need of electrons. Similarly, CH3 plus, that is carbocation, has 6 electrons in its valence shell. It is in need of 2 more electrons to complete its octet. So it is also an electrophile. Similarly, RC double bond O plus charge on C, this is called acylium ion. This is also an electrophile because this central carbon atom is having this from double bond 4 electrons, from this single bond 2 electrons. So the central carbon atom is having 6 electrons in its valence shell. It needs 2 more electrons, so it is also an electrophile. Similarly, nitronium ion is also in need of 2 electrons, so this is also an electrophile. And nitrosium ion, NO plus charge on nitrogen atom, is also in need of 2 more electrons to complete its octet. So this is also an electrophile. Now let's see what are neutral electrophiles. Neutral electrophiles do not have any charge on the central atom. For example, BF3, AlCl3, FeCl3. Now you can see the central boron atom is having 3 bonds, 3 covalent bonds formed by fluoride ion. electrons, fluoride atoms. These fluoride atoms are being more electronegative, pull the electrons towards themselves, as a result of which this boron atom develops partial positive charge, that is delta plus on it, so it becomes an electrophile. Similarly, in AlCl3, the halogen atoms, that is chloride atoms, being more electronegative, pull the electrons towards themselves. As a result, Al becomes partially positive, so this becomes an electrophile. Similarly, FeCl3, the chloride atoms, being more electronegative, pull the electrons towards themselves. So, iron atom develops partial positive charge on itself, so it becomes an electrophile. So, these are neutral electrophiles. In these neutral species, the central atoms develop partial positive charge as the more electronegative halogens pull the shared electrons towards them. So, these are the species that are electron loving and electron deficient. So, they are called electrophiles. Thanks for watching. Please share, subscribe and like. Thank you very much.